In terms of methane, the palette of sectors is a bit different. We have agriculture, waste, and fossil fuel extraction, if we look in the global perspective. Now this shows also the, as I will focus specifically on black carbon and methane, this graph here shows the importance of the Arctic Council countries in terms of black carbon and methane. First of all, methane is a well-mixed gas, so it doesn't really matter where you reduce the emissions. But the Arctic Council countries then again have 20% share of the pie, and of this the oil and gas sector is about 11%. In terms of black carbon, if you look at the global split, the Arctic doesn't play such a big role. It's 6% and only 1% for the oil and gas. But this changes when you look into the impact, because black carbon is much more short-lived, only just about a week in the atmosphere. So this means that it's very concentrated towards the source areas. And we have, as I will show soon, significant source areas in the high north. But let's begin with oil and gas, and let's begin with global methane. This highlights a very recent development done at IIASA by my colleague Lena Höglund Isaksson, and she has just published this result. And it's a comprehensive work on putting together an oil and gas emission inventory for the globe since 1980, so really appreciated work. So with these black lines you see other emission estimates that are there, which tend to, in my opinion, really underestimate a little bit some sectors. So what has been done basically is that there is differences between the inventories, and she has put a lot of effort in trying to mine out all the missing gaps in knowledge just recently. What you see here is a significant reduction in this red area, and this is the associated petroleum and gas venting. So more and more utilization of this APG has become available globally, and this of course affects the methane emission through the venting, as well at the same time the flaring emissions, which is relevant for the black carbon, which I will show next. Another interesting component in this graph is the unconventional gas, which has just recently been started to be extracted globally, and these are sort of new components to the overall inventory. So after this work, Lena has continued cooperation with atmospheric modelers, and indeed they have found that the match between the measurements has improved significantly after these updates. And using ethane as a marker for fossil fuel combustion, even that, which is a component of the emission inventory, also that match has improved significantly, and there will be more to follow. There is a group of scientists publishing this work in the Nature Geosciences, hopefully in the near future. Now talking about oil and gas still, but moving towards black carbon emissions. This map shows an Arctic perspective of the black carbon emissions, indicating red hotspot areas there in the high north, Siberia, a couple of places. Of course, some we see also in my home country, Finland, but that's a different story in this case. If we match this with nighttime lights taken from NASA satellites, looking at the specifically Arctic area, also the same projection, we see an incredible match with certain areas. And if we further match this with black carbon in flaring, we see that indeed these biggest hotspot areas are correlated with the black carbon emission releases. So definitely flaring and black carbon emissions from there appears to be a major source beyond the polar circle and in high north in general. And indeed it might be responsible for a very significant share of the black carbon burden in the Arctic. And I was very happy actually yesterday to hear from the Ambassador Babin's speech that Russia has taken significant policies in the Arctic context to reduce the flaring. Of course, they have done that for a couple of years already, but not really. I haven't heard that in this Arctic context, in that strength, let's say. So gas flaring, as shown in the first slides, is not extremely big thing globally, but for Arctic it is. So the Arctic Council nations can actually cut down significant share of their emissions, collective emissions with this sector policies, actually almost, according to this analysis, covering their black carbon goal that was just recently adopted a few months ago. Now moving from these emissions into impacts, this is showing now the temperature impact of reduced SLCP emissions in 2030. So this is now not only oil and gas, but it actually talks about emission reduction technologies for both black carbon and methane, which has been found to exist already. There's no new learning needed to develop these technologies. They exist already. And if implemented by 2030 fully, this would really mean a lot for perhaps the globe, but especially the Arctic, as shown in this figure. So we see here the temperature curve. On the negative side is the reduction in temperature due to these emission reduction possibilities. And we see that especially in high north, in the high latitudes, there's a big share of this mitigation happening. So how will these come to be? So if we think about black carbon, for example, we see that of course the Arctic Council countries have a share to do. So according to AMAP's analysis, about 30% of the Arctic warming is because of the Arctic Council emissions. Despite in global anthropogenic scheme it was only 6%. However, as this graph shows, this sort of shows a multi-pollutant approach and temperature effect in the Arctic surface. It shows very significantly with this round, red round dot here, that the rest of the world plays an important role. So, of course, the question is where the 70% comes then from. It comes from more southern latitudes. And the pathways are, of course, direct transport of black carbon and other pollutants and methane into the area, but also the transport of warmed air masses from more south that mix into the Arctic air masses, and in this pathway also warm the area. This picture then just shows, I'm coming from a Nordic country, and one could argue that from our perspective that, okay, we have 1 per mil of the global emissions of black carbon, why should we do anything? But if we look at the Arctic perspective, and we are a member of the Arctic Council, we see, and this is now the Nordic countries, this is the net climate effect of several pollutants in the area. But we see that the more north we go, the more a per unit emission, the more it matters. So that's why we, the Arctic Council, of course, have the special responsibility to do something about these emissions. But as said in the previous slide, there is significant things to do also elsewhere. And that's why in the Arctic Council, the whole process of working with short-lived climate pollutants is very inclusive also for the observer countries, and why not the rest of the world. So to summarize, global mitigation of SLCPs could cut near warming, and if sustained and associated with CO2 reductions, could contribute to the limiting warming of beyond 2 degrees. The SLCPs have health and ecosystem impacts, so we would get benefits also on these areas. And we have a pronounced Arctic warming connected to these species, methane and black carbon and others. In case of black carbon, the high north emissions have a specific importance and responsibility, but it looks like that we really have the solutions in place already. So it's actually what is lacking is the policy to do it. And we have heard already during this conference that for flaring, hopefully there is a future, but we have to work on the other sectors as well. So with these words, I conclude my talk. Thank you very much.
Thank you very much, Carla. We'll save the questions for last and continue with Thomas Gasser on permafrost and economic issues.
Good morning, everyone. So I'm Thomas Gasser, I work at IIASA, and I'm a climate scientist. and I'm going to show you a study where I am currently leading on permafrost thaw and how this affects emission budgets. That is, how much humankind can emit before reaching a given temperature target. So this is an example of how at IIASA we try to have an integrative approach to things, although this part so far is just focused on the natural system. So I have to make it short because we're running late. So, but let's try with the basics. Let's start with the basics. Permafrost is this soil that was completely frozen, permanently frozen during pre-industrial times, and now because of global warming, the soils are thawing. And this makes the organic matter in the soil available for bacteria to consume and then release CO2 and also CH4 if the oxidation is in anaerobic conditions. So this extra greenhouse gas emission will have an impact on how much we can emit if we want to limit global warming to a given level. So very briefly, it seems obvious, but permafrost thaw is a positive feedback in the Earth system. So we have to realize and understand what is the basic cause-effect chain in the Earth system. So when we emit CO2, this increases the atmospheric concentration of CO2. There are some exchanges with the land and the ocean components of the Earth system, which are called together the carbon sinks, which is a negative feedback. About 50% of what we emit is removed from the atmosphere by the carbon sinks. But still, atmospheric CO2 is increasing, so we create a planetary energy imbalance, which increases the temperature. There is one well-known feedback in this system, that is the climate carbon feedback. So with an increased temperature, the carbon sinks are less efficient. So this is a positive feedback. So it's important here to add to the picture the non-CO2 species, especially CH4 in our case. And what we want to do, or what we did rather, is add permafrost thaw again to the picture, which is again a positive feedback. The warmer the world becomes, the more permafrost thaws and the more CO2 and CH4 is emitted. So this feedback is slowly being put in equations and integrated in complex models, complex three-dimensional models that are used for climate change projections. And now the teams working on that can produce some projections of what permafrost thaw and permafrost extra emission will be and what will be the impact on the climate. The main problem is that those models, because they are complex, they take a lot of time for the computation, sometimes weeks, even sometimes months. So they cannot have a completely integrative global approach, and they are not fully coupled to the whole system. So to have a fully coupled model, what we do, what I do actually, this is basically my job. I've developed an emulator of the complex models, so you don't have to understand all those plots, but the idea is that with simple, smart equations, we try to reproduce the behavior of complex models. And then we use this emulator of the complex model, we put it in another emulator of the whole system, which is called the Oscar model, and we can then run many simulations. So this is an example of the effect. I don't know if you really see, but that's not the main point. So once we have this emulator, we can run many scenarios, and the results I'm going to show are based on about 16,000 scenarios, going up to 2,500. So now I need to talk about emission budgets, of course. So this is a concept that basically appeared before and during the writing process of the last IPCC report. It is based on an approximate linear relationship between the peak temperature change, I should say, and the cumulative CO2 emissions. So all the CO2 emissions emitted by the humankind in the past and in the future. And so this is on the right-hand side. This is a famous figure from the last IPCC report, in which you can actually basically read what is the budget and how much you are allowed to emit if you want to reach a given level of temperature change. So typically, when we look on the y-axis, choose a target like 2 degrees, then look at this more or less linear curve and deduce on the x-axis the total amount of CO2 emission that we can have. But actually there are different definitions, and I won't go into the details here. I just want to say that because permafrost thaw is a slow process, the IPCC approach is actually not the right one. So we have to use another approach, another definition that is based on many scenarios, hence the 16,000 scenarios. So all the scenarios are peak and decline scenarios. We take the peak temperature, the peak cumulative CO2 emissions, and then we interpolate how much we can emit for a given target. So don't know if you can see that, but that's illustrated in the on the middle panel here. This is just an example for a 2.5 degree target. You can see 2 black bars. The one that's more on the left is the one when permafrost thaw is accounted for, and the one on the right hand side is when permafrost is not. So quite logically, because this is a positive feedback, permafrost thaw reduces the amount of CO2 we can emit. So as I said, we can make simulations for many scenarios, for actually many definitions, for many non-CO2 scenarios. I said non-CO2 are also important in the system, for different targets, and we get that kind of results, like this big picture, which may be difficult to understand, but I think there are a couple of main ideas here that are quite actually in some way just logical. So the budgets are reduced, whatever the definition, whatever the target, whatever the scenario. The higher the target, the bigger the reduction. And if we overshoot the target, that is, if we reach a given level of temperature, if we go above the target and then we want to go back to the target, permafrost thaw also has a bigger impact than when we just stay below the target. So I try to sum this up in this figure, which summarizes the effect of permafrost thaw. So, and this is actually my concluding slide. Basically, there are 2 conclusions. First is that we have a systematic reduction of emission budgets because of permafrost thaw, and depending on the target, this reduction can be actually quite high. So, in terms of total budget, permafrost thaw doesn't impact that much the budget. It's a few percentage points, but we have to account for the fact that we have emitted already a lot of CO2. So when we remove this already emitted CO2 and we just look at the remaining budget, the impact of permafrost is much, much bigger. But so the second conclusion of our study is that the effect of permafrost is actually scenario dependent. So the initial linear relationship that is used to deduce emission budgets, basically doesn't hold, because permafrost thaw is a strong non-linearity of the system. So what we find is that, for instance, for a 1.5 degree target, if we have access to negative emission technologies, that is, if we can actually remove artificially CO2 from the atmosphere, then the permafrost effect is just a reduction of about 15% of the remaining budget. But if we don't have access to these technologies, the reduction caused by permafrost thaw is about 45% of the budget. Because we have no way to artificially create a peak of temperature. So only the natural system would decide when the temperature is actually peaking. That could be that could be later than without the permafrost. And if we look at the 1.5 degree target overshot by 0.5 degrees, so that is exactly the target of the Paris Agreement, we have a reduction of the remaining budget, of about 30%. So that's it. That's my conclusion. That's the conclusion of our study so far. Basically, two take-home messages. Permafrost reduces the budget, but it is scenario dependent. Therefore, there is no unique budget. And if you want to use the budget to do some policy planning, you have to decide whether those negative emission technologies will be available and whether you want to overshoot or not your target. Thank you.
Thank you very much, Thomas, for the second example of IIASA research. And the third example is on participatory approach, which is actually key in the Arctic Futures initiative. So we are working with the stakeholders and you actually to develop and implement the project. And the presentation is by Lassi Heininen, and it's on participatory approach and systems, policy shaping and policy making.
Thank you, Anni. Good morning. I was thinking that I share some of my thoughts and really hope that there will be both time and eagerness for discussion. IIASA's new project, Arctic Futures Initiative, it's dealing with the future. So can you imagine future without actors? So, and actors, can you have policy making without actors? Can you have policy shaping without actors? But it matters what kind of actors we are talking about. If you have had time to read this flyer, so it said that Arctic Futures Initiative aims to answer the need for a holistic, integrated approach to the development of the Arctic in variety of actors with different values. So, okay, it's rather general definition. Of course, it's inclusive. We welcome all those who are interested in. And then in the back page, there is a long list of different participants who have been contributing, who have been involved in. So there is no term stakeholder there. But then, in many other contexts, particularly in the Arctic recently, we have seen that the term stakeholder has been used several times. And there are those who are, in a way, saying that they would like to become stakeholders of the Arctic. They would like to become Arctic stakeholders. So I'm a little bit struggling here and when thinking this, that, well, I mean, what does it mean? How we define a stakeholder? There is very general definition that a stakeholder, meaning corporate law or project context, is a person, group, organization with an interest in a project or a matter. Well, again, I mean, very loose general definition. What does it mean? And I think that this is something what in the context of AFI we would like really to look for and have some kind of analytical work, some kind of analysis and synthesis report where we are making an inventory. What are the actors who have been contributing? And then and compare these actors between each other based on what kind of stakeholder each of them is. And also to make a list of contributions by all relevant stakeholders. So what is that what they have brought on the table? And analyze how they have impacted, how effective how they have impacted these stakeholders, and how effective these contributions have been or are. And I have not seen that this has been done really yet. And I think it's rather relevant, I would say. And in a way, I'm coming from international relations, international politics, if you wish, and there, the textbooks, they say that there is not any one list of international actors. There are several lists of international actors, but there are certain categories of international actors, starting from unified or nation states, and then going to intergovernmental organizations, going to subnational governments, and then going to international non-governmental organizations, and then finally transnational corporations, and nowadays also in the Arctic context, state-owned enterprises. So there you have 5 important categories of international actors. And then of course it's very rich dynamics if you think about the interrelations between these. Even within one category you have many interrelations. But that is that rather traditional approach when we think that it's all about states. But we cannot, because, and now I'm coming to policy shaping. So I wanted to have here not only policy making, because we think that you have to have authority to make policy. But you don't need authority to shape policy. And this is exactly when we, this is exactly in the Arctic context when we have seen that non-state actors, they have shaped policy a lot. Even this Arctic Circle is a good example of that. Although, okay, it was a head of state who started this. But then from the very beginning, it has been an inclusive platform for all those actors who would like to come and give a contribution. And then, but now we have had also newcomers in a way, like few non-Arctic states. And if you read carefully, there are sometimes mentioned that, I don't want to mention any names of countries now here, but in those agendas or policies, it's something saying that we are becoming an Arctic stakeholder, or we consider ourselves as Arctic stakeholder. So that means that then it is a conscious decision. We are not anymore only objecting, but we are also would like to become and shape policy. And we know that the observer countries of the Arctic Council, they are very careful not to say that, no, we will not come to make policy, because it's up to you, because of state sovereignty. But we are here interested in, and then becoming, then they are shaping policy, of course. But however, we have a little bit problem here that you declare to yourself to become a stakeholder, meaning that you have a legitimate right to come and shape policy. Well, you may have, but of course that means then we have to discuss more. Then there cannot be only state sovereignty there. Then we have to bring on the table the discourse on global commons. And I can say that the Arctic states, they don't like that discourse today. And the observer countries, like I said, they are very careful not to bring it up. But the reality is they're saying that we are there already. We should discuss on that. So the reality is that you forget the traditional list of international actors because there are so many of those who are already there shaping policy. And that is what we really would like to study out, that what does it mean and who are really becoming subjects of policy. So to shape policy does it mean that you will become a subject of to make policy? Well, again, it depends how you define it, but not necessarily. And here I would like to make to have the difference between policy making and policy shaping, because actually it has been much more important. I mean, the policy shaping, what has been policy making. And to me, policy shaping is before policy making. And it's good to carefully think and maybe rethink what are the decisions you would like to make. And this is, for example, in security research, security studies, one of the most fundamental questions is who are subjects of security? Traditional answer is very clear, states. And that's it. But if we think about pollution combined with rapid climate change as a super big problem, then it's not enough at all. Then you need other actors becoming there. So this is what we would like to do, and then this is something that I really would like to welcome those who are interested in, and then let's problematize this and then have a more analytical approach. Thank you.
Thank you very much, Lassi. And as you saw, we went to the other end from the first presentations to the other end of AFI, but these are closely connected and very important. And now it's your turn. So first questions to the presenters. Please, do you... Okay, please.
So there's this general expression that what happens in the Arctic doesn't stay in the Arctic. So when working in a systems approach, are there some inherent difficulties focusing in the Arctic and building out the boundaries of these systems that you're trying to research, since it's so interconnected with other regions?
I would like to turn the question to the opposite. We are coming from the global perspective. All the models which were shown here and many others are actually global models, having a balance between the physical, biological, ecological and economic systems. So it is more a question, are we actually able to downscale and zoom in into the local rather than other way around. But these teleconnections, this nested system, as you refer to, is the very heart of the whole issue. Let me just be very practical and give you some examples. We have been listening here to the amazing stories of speed and the rate and the impact of the development of the northern route, right? We see what happened there, we see how it goes, we see the frequency of the ships passing, we see the success of Yamal, for example. If you put this into the perspective, how sustainable in terms of the economic viability and the sustainability in large these scenarios are for 2030, it doesn't depend only on the way how technology can conquer the northern route. It depends, for example, on the choices being made as we speak in Tokyo about which direction the Japanese energy outlook goes. Would it be the LNG-based Qatar import, or would it be something else? This type of teleconnections, I can go like that for a whole afternoon, are completely missing in the current discourse. So this is where we are coming from. We would like to explore these examples, explore the viability of these, and definitely in the context of the global teleconnection, because we believe that they actually determining more the Arctic futures and fate rather than the local bottom-up processes.
Okay, next question, please. Yeah.
From Global Infrastructure Basel Foundation. I just had a question for the last gentleman. Because there's a very clear definition of what scale, there's a whole science behind stakeholder outreach, stakeholder engagement, what we've done with our standard, with the standard for sustainable infrastructure. So I'm just wondering, normally for stakeholder engagement, you do have various stakeholder groups, but I have this feeling now that it's very limited. For me, another stakeholder group, the definition is someone who has a stake in something, or something is at stake for someone. So where are the other groups, the civil society, business, are they also engaged in that process, and how far?
Yeah, thank you. I had a little bit problems to hear because of the echo of the room. But if I understand right your question, so I mean, stakeholders are not equal. I mean, they are in different positions, and that's why the influence is different. But I mean, my point is that if you think that to become a stakeholder means that you are bringing something on the table, because the stake is there, yeah, your interest is there, so that then you are sharing some interests with others, and then you would like to contribute, and then it's of course you will benefit, but then it's a win-win situation, and then you in a way you will become a subject. You are not only depending what the others are doing, you are also impacting, influencing. And this is what I would like to see, that we are more carefully, when we use that term stakeholder, we will demand that what you will bring on the table. And this would then lead us into a discussion that yes, I mean, we are here to contribute and to share. Yep, please.
There will be definitely in this discourse winners and losers, at least in the current framing of the problem. But we believe that this reconciliation framework to which we are trying to provide data could be a very interesting framework before we declare there is a group of winners, a group of losers. And I'm sorry to say, in the current setting, we are still in this space, losers and winners. I mean, I'm questioning, for example, discourse of the feedbacks and interaction between the Economic Council and the Arctic Council. The feedback and discourse is not defined, as an example. So there is a kind of perception about losers and winners. This social political science perspective, just to illustrate how this can be combined with the IIASA other part, will be and should be combined with the perspective where we have actually theoretical approaches how to strike the deal in the conflicting environment. And there is one colleague in the room, Dr. Dickman, who is leading the program about how to use these game theoretical approaches to come to areas of satisfaction which are much bigger than you would perceive based on this division of stakeholders and those who are winners and losers. Maybe Ulf, you could say something about how did it work for the Arctic fisheries, because we have done this particular research, and the amazing outcome was that you could actually achieve 80% of satisfaction of all the stakeholders by involving the combination of the agent-based and game theoretical approach. Would you like to comment on that?
Yeah, you referenced a little bit. We will have a session at 17:30 in the afternoon on Arctic fisheries assessments, and you're all welcome to come there, where we can give you more details. The principal idea that we want to promote is that the non-traditional, non-biological objectives that society and stakeholders care about are currently not part of quantitative assessment. The quantitative assessment stops at the biological level. It's extremely well developed at that level. A lot of money goes into surveys and into the scientists analyzing the data. And then the resultant recommendations about quotas are handed into a political process where supposedly the other objective and the other stakeholder are reflected in a very qualitative, in a very necessarily subjective way. And we wanted to find out how to make this second part, this non-biological part, to integrate it into a quantitative assessment, to see how far we could go with that. And we had a pilot on the Northeast Arctic cod, which many of you will know is one of the most important and valuable fisheries in the Arctic zone. And we found that once we quantified interests such as employment, such as profit, such as ecosystem preservations, and made them part of the quantitative assessment, there was much less polarization and much more reconciliation opportunity than the public debate seems to suggest. So once you have a common good, sometimes, not always, the overriding interest is to preserve it, and that, in a sense, unites the stakeholders into actions which are far more compromise amenable than much of the public debate suggests.
Thanks very much, Ulf. And again, there's the fisheries session of IIASA is at 5:30 today. And before that, there's actually another breakout session coordinated by IIASA as well. It's on Northern Sea Route, its impact on global trade. And I think that's an interesting IIASA type approach, again, with several guest panelists involved, and coordinated by moderated by Ambassador Hannu Halinen. So more questions? Lars Otto? More questions? Okay, please.
Say, Glenn Page, University of Dundee, and Sustained Metrics. Amazing what you're doing. Really impressive. The integration, the synthesis, the pathways. The key question is, how do you learn? How do you look at yourselves with the reflexivity on the initiative and build learning into the process? Because you're clearly inclusive, you're clearly ambitious, you're global, and you're breaking paradigms. So there really is no roadmap, and so therefore learning, I'm sure, is a key function. How do you integrate your own learning into the process?
Let me just start, and my colleagues may help. First, thank you for intervention, and of course you hit the nail on its head. And so, by the way, I see this statement as a kind of first step towards working with us, hopefully, yes, because that will be good. And surprisingly, I will go to some other example where the question is as well. IIASA has been in a very privileged position to inform by such a similar calculations the process which led to adoption of development goals. 2015, 193 heads of states adopted this fantastic agenda, perspective for the future. We have been doing calculations behind the scenes because we are non-governmental but close to government, so most of the data came from us, from education all the way up to energy. And then we brought it to New York, and then of course we had this big thank you from Secretary General Ban Ki-moon and every head of state, and then they said thank you, and then I said, well, is it it? Well, thank you. And then I said, how are you going to implement it? How are you going to? And then I put this fairy tale of Shakespeare. I said, look, this is goal number 1, this is goal number 3, this is goal number 17. As they all are in the space, we don't know how they interact, right? So let us be partner. Let not science leave the stage, and let's be a partner in this implementation. So we have started a project called World 2050, in which we are trying to use a similar systemic integrative approach towards the interactive thing. Now, the best thing comes now. I've been sitting together with Jeffrey Sachs and with Jan Dostrom and with Secretary General Ban Ki-moon on table, and try to explain that this is not a proposition for a project. This is a proposition for the long-term partnership. Because in the terms of Lassie, science is not a stakeholder. It doesn't have a stake. It must be a partner. For the very same reason you say, because this is a process of learning, process of changes. At the moment you push out scenario, the externalities may change. So you've got to be part of the process. So this is what we've been trying to promote, to say, this initiative, although I said this morning that we need a quick, fast track, little bit dirty start, I actually believe, and this is my dream, that when this takes off, when we come here next year with many of you to show zero-level assessment. When we come here 5 years later with that big assessment, actually this will become a 30-year partnership when this learning process will come back to enrichment of the scenarios, all of that. You know, sometimes it's so simple but so difficult. When IIASA produced in 2012, after 6 years of effort, with 500 scientists across the world, the most groundbreaking energy outlook for the world, called Global Energy Assessment. We brought it to Rio de Janeiro, area post-20. It was adopted immediately. There is a 500 billion pledges made within a month after its adoption. But it was based on the state of the world in 2012. I came to IIASA in January in 2012. I remember there was this big discussion about where you set the threshold of the minimum oil price in this scenario for the next 30 years. So what we did, we picked up the phone and we called CEOs of the largest in the oil sector of this world. From Rosneft to Total, from Total to BP, from Shell, and to OPEC. Would you guess, this is a simple question, what is your most qualified guess of the lowest price of 1 barrel of oil for the next 30 years? Simple question. Try to guess what was the lowest estimate by all of them. We spoke to 9. 80 US per barrel. A year later, we were down to 40, right? So what you can do is you can throw away these scenarios, or you can start to calculate again. Can you imagine what would happen to our recommendation to go to photovoltaic when the competitiveness with the oil was 80 versus 40? So this learning process goes all the way around. So we need a partnership, and that's why I'm grateful to President Grimson. He understands. He does understand this is a long-term partnership rather than a scientific research project. So thank you for the question. Yeah.
Thank you very much. Are there more pressing questions? Not really. Okay. Just a glimpse of the upcoming years at the Arctic Circle for the Arctic Futures Initiative. So we will be coming back on an yearly basis, and next year we will also present some analysis and synthesis reports of Arctic nations' strategies, and also Arctic Council, and also what has been going on at the Arctic Circle assemblies since 2013 up to this year. And I think this is really interesting because it's key work what we'll be doing, systems analysis and synthesis, and also we will be organizing probably pre-meetings, workshops during the Arctic Circle, which will have a strong participatory component, but it will be something that it will be the whole chain, the whole process. So it's a participatory meeting, but it has the pre-meeting and meeting and post-meeting components that contribute to science and increased knowledge for us all at the same time. So this is also one of our ways of working, and we'll get back to the stakeholders and the decision makers with the results on a continuous basis. So I thank you very much. I thank you for your patience in the beginning, and please join our two other sessions this afternoon, and you will hear from us, and please get back to us on any input, comments, and naturally we collaborate with you all. Thank you very much.
That was a real pleasure.